Hello, and welcome to this presentation, Configuring Analog Signal Generation on the SMA100B. In this presentation, we'll show you how to generate basic analog signals with SMA100B and explain the various settings you can use to optimize these signals for different applications. This presentation assumes a basic knowledge of signal generators. If you're unfamiliar with basic RF signal generator concepts, it might be a good idea to watch the presentation Understanding Signal Generators before continuing with this presentation. The two most important settings in signal generation are frequency and level. The frequency of the SMA output can be set by using the frequency hard key, by clicking on frequency in the status bar, or by clicking on the frequency tile and choosing frequency from the menu. The frequency entered in the RF frequency menu is always the same as the frequency coming out of the front of the SMA, but as we're about to see, the frequency shown in the status bar may change based on so-called offset and multiplier parameters. A frequency offset can be useful when there's a downstream frequency shifting device, such as a mixer. Entering an offset changes the frequency value in the status bar. Here, we add 455 to 919 and get 1374 MHz. Note, however, that the actual SMA output frequency does not change. The multiplier works in a similar way when we have a downstream device that multiplies the frequency, such as a frequency multiplier. Entering a multiplier changes the frequency value in the status bar. 919 times 5 equals 4595 MHz. But as before, the actual SMA output frequency does not change. PLL bandwidth can be set to either normal or narrow. Setting the PLL bandwidth on the SMA to narrow improves phase noise performance, but it also decreases the maximum modulation bandwidth. If you need the best possible phase noise performance, setting the PLL bandwidth to narrow may provide an improvement. In different places within the SMA100B, you may come across a setting called user variation. User variation simply controls the step size when using the rotary knob on the front of the SMA. For example, in frequency mode, the default step is 1 MHz when using the rotary knob. By enabling user variation, we can define how much each click of the knob changes the frequency. For example, if we enable user variation and set the step to 2 MHz, each click of the rotary knob will change the frequency by 2 MHz. User variation can also be used for other parameters, such as level. Signals transmitted by the SMA normally have a 0-degree initial phase angle. If we want to shift this initial phase angle, this can be done using the phase settings. For example, we could set the initial phase to 45 degrees, 90 degrees, or 180 degrees. Reset delta phase display can be used to set the current phase as the reference value. The delta phase setting is particularly useful if a common reference signal is shared between multiple instruments or DUTs. For example, delta phase could be used to create a 90 degrees phase difference between the signals from two different generators. Now let's move on to level settings. As with frequency, we can set the level of our generator output using the level hard key, clicking on level in the status bar, or by clicking on the level tile and choosing level from the menu. The level coming out of the SMA is always the same as the level, or amplitude, entered in the RF level menu. We've already seen how the frequency offset works, and a level offset works in much the same way. This offset represents a level shift caused by a downstream device, such as an amplifier or an attenuator. We enter a positive offset for a downstream device that increases the level, and a negative offset if the downstream device attenuates the level. And as before, although the level value in the status bar incorporates this offset, the amplitude of the SMA100B output is not changed when an offset is applied. It's fairly safe to say that all RF devices have a maximum input power level, above which distortion or actual physical damage can occur. This includes radio frequency test and measurement equipment, such as spectrum analyzers and power sensors as well. The output power of the SMA may exceed the safe input level for a device, especially when the SMA is configured with the high output power option. For example, a properly equipped SMA can go up to plus 38 dBm at frequencies under 6 GHz, and this substantially exceeds the safe input level of most spectrum analyzers and power sensors. Therefore, the SMA has a limit setting which can be used to prevent the output power from exceeding a user-defined value. We mentioned before that performance or spectral purity is very important in analog signal generators, and there are a number of advanced parameters that can be changed to optimize the performance of our generator in special circumstances. These are setting characteristics, mode, harmonic filter, attenuator, automatic level control, and user correction. Note that many of these advanced settings only make a noticeable difference in special circumstances. Setting characteristics can be used to optimize the RF signal level behavior for different applications. Although there are numerous different setting characteristics, the two most important of these are auto and uninterrupted. Auto mode provides the fastest setting times and the highest dynamic range, here -127 to +25 dBm. However, in auto mode, the RF signal may be briefly blanked or turned off as we change level over this range. This is due to switching of the internal step attenuator. Uninterrupted mode, on the other hand, avoids this level blanking, but the level range is reduced. Here, our level range now drops to only about 18 dB. Note that even if we stay within this range in uninterrupted mode, blanking can still occur if our frequency changes. Mode allows us to optimize our RF output signal for improved harmonic distortion or improved wideband noise. There are three different modes. Normal strikes a balance between signal-to-noise ratio and distortion. Low noise optimizes our signal-to-noise ratio by reducing noise, but at the cost of increased distortion or harmonics. Low distortion, on the other hand, minimizes these harmonics or distortion, but decreases our signal-to-noise ratio. The SMA100B has a filter designed to reduce the level of generated harmonics. In the auto setting, the harmonic filter is selected based on current level settings. Setting the filter to on ensures the best harmonic performance, but also reduces the level range. One of the ways that the level performance of the SMA100B can be improved is through its built-in electronic step attenuator. There are several cases where using attenuation is beneficial, such as when testing a DUT under low signal-to-noise conditions. There are two modes for the attenuator. In auto mode, the generator automatically adjusts the attenuation of the RF output signal, whereas in fixed mode, the attenuation remains constant. Fixed attenuation values are required if you need uninterrupted level settings with constant VISWAR, and you'll see different level ranges depending on which mode you choose. The other setting under attenuator is the RF off mode, which changes the attenuation when you turn the RF output off. Unchanged maintains constant VISWAR, whether the RF signal is on or off. Full attenuation sets the maximum attenuation, and thereby suppresses noise when RF is off. This is important in noise-sensitive applications. Another way of optimizing level accuracy on the SMA100B is through automatic level control, or ALC. ALC is an adaptive control system to stabilize the RF output level. It continuously monitors the current level and adjusts it to keep a steady state over temperature and time. ALC is active in almost all applications by default, but level control can be implemented one of 4 different ways depending on state. As the name implies, auto selects the most appropriate ALC mode automatically, while on activates ALC continuously. The on setting provides the highest level accuracy, and also maintains the level even when ambient conditions, such as temperature, are changing. The other 2 ALC states involve an internal table. Remember that ALC is a control loop, so the output is based on the history of the signal. Off uses the internal table rather than history to control the attenuation values. Table and on starts with the attenuation settings from this table, and then activates the automatic level control. This improves setting times when something in the RF path changes. In the case of pulse modulation, this mode ensures fast level setting, even with narrow pulses at low repetition rates. Finally, the sensitivity of the detector used for ALC can also be set to either auto or fixed, but in almost all cases, it's best to leave this in auto mode. User correction allows you to select and/or create user correction data. This data is in the form of a file that adjusts the level of the SMA depending on the current frequency in order to compensate for an external frequency response. If you'd like to learn more about user correction, please watch the presentation Configuring User Correction on the SMA100B. Let's end with a brief summary. The 2 main parameters in basic analog signal generation are the frequency, which also includes the initial phase of the signal, and the level, which on the SMA100B also includes an output power limit for safety reasons. We can also specify both frequency and level offsets to take into account the behavior of downstream devices, such as mixers, amplifiers, attenuators, etc. Remember that signal purity or performance is very important in many analog signal generator applications, so there are many different settings for adjusting or optimizing generator performance. The proper selection and configuration of these advanced parameters is a very advanced topic, but it's good to have a general idea of what each of these settings does and where they might be useful. And last but not least, user correction can be used to compensate for the frequency response of external cables, connectors, etc. This concludes our presentation configuring analog signal generation on the SMA100B. If you'd like to learn more about signal generation or signal generators, please see the links in the video description. Thanks for watching.